Today I'm going to show you how to do a modulus for really big numbers, but a faster method than before. The previous video I show you how to take the modulus of a really big number and it just subtracts the divisor from the dividend until you get the remainder. And that took a lot of iterations to complete. So for example, using that function method, it took this many times to get the remainder of 0. And as you can see here, we have dividend, divisor, you subtract 23, all the way down to here until this dividend is 0. And that's how many times it takes. The faster method, it only takes 36 times opposed to this many times just for this number. And the way I do that is, so I take the dividend and the divisor and I multiply the divisor by 10 a bunch of times, but it's always less than this number, dividend. So I take 23 times 10 times 10 times 10, but it always has to be less than this number, and they subtract that number, 23 something, from here. You keep doing that, you multiply 23 times a bunch of 10s, you keep doing that until you get down to here, and you're subtracting just 23 at the end. Okay. Alright, and here's my function right here. So it takes in dividend, which is this just is unsigned integer 64-bit. So this is an unsigned long integer. That's what all these stand for. So it's the same thing as writing unsigned long integer. So you have dividend and divisor. It takes in those two, takes in positive integer and dividend, and then it returns remainder. Okay, so first I set up a variable. This is just a count variable to count how many iterations. It's not necessary. I have a temp dividend, an epsilon, which is going to be that 23 times 10s, and it's going to start out as the divisor. So for that example, it's going to start out as 23. I'll just use these numbers for the example, by the way. Then I have a temp epsilon. So this right here, this just says if epsilon, which epsilon is equal to 23. Epsilon 23 is bigger than the dividend. So if you're trying to divide by a number bigger than the dividend, it's just going to return with an error because we're only dividing by things that are smaller than itself. Here's the main function right here, the main while loop. So from before, we did this in the previous function, while the dividend is greater than the divisor. Before, you were just subtracting the divisor from the dividend until it's less than. So same thing applies here. And then inside that while loop, so first every time we're going to set epsilon to 23, or the divisor, and then the temporary epsilon is going to store that epsilon, just because it's going to be less than what we want in this loop. Okay, now I have the example picked up. So right now, this is 23. So while 23 is less than this really big number, that 23, so first it stores 23 into here, and then multiplies 23 by 10, so now it's going to be 230, and it's still less than this really big number, and it's going to keep looping until it gets to this number. That number is stored in temp epsilon, and then it's going to multiply it, so it's going to be bigger than this number, but we're not going to use that number because that's why we have the temp. The temp epsilon is then subtracted. This temp epsilon, this really big number, is subtracted from this number right here. Each loop iteration in this while loop. And that is it. And we count each time just so we get, it's not necessary, it's just adding how many iterations it takes to finish this. And print the count, and I return the temp dividend, which is going to be 23 or less in this example. And to test this, I just have, so first I do dividend divisor, and the divisor is bigger than the dividend, so it should give error. Then I do 10 divided by 5, should give remainder of 0, and then 1. Same, this should be 0 and 1, and it should take 2 iterations, 45, 36. So 10 divided by 5, 11 divided by 5, this big number divided by 23, that divided by 23, and then just some other examples. So save that, compile it, run it, and first I get the error, 10 divided by 5, remainder of 0, 2 iterations. Same thing for 11 divided by 5, one remainder, 2 iterations. And now we get 45 iterations for this really big number, as opposed to this many iterations. So this algorithm works a lot better than the previous one. I don't know if there's any faster algorithms. I haven't really thought of them yet. Maybe something to do with squaring the divisor sometimes works. Who knows? I'm going to work on a faster method that, well, not a faster method, but I'm going to do it for even bigger numbers than unsigned long integers. So there will be a part 3 eventually for numbers that exceed the limit of the C data types that you're given. Thanks for watching. See you next time.